This was a 3-year study that I have been working on. We did this starting in 2014 up until this year as well, where we were really looking at both berry maturity and wine alcohol on the impact of different phenolics. So Khan did a great job introducing these compounds that I'm going to be talking about today, so I'm not going to go into too much introduction here. But the phenolics that we were really looking at were monomeric anthocyanins, which are what provides color to your berries and to your young wines, and tannins, which are responsible for the astringency. Once you get anthocyanins extracted into wines, they are relatively unstable. So they get bleached by bisulfate, they have pH shifts, and they react with a variety of compounds in the wine. Most notably, what they're reacting with are tannins to form these pigmented tannins or polymeric pigments in your wine. And these polymeric pigments, as we've heard throughout the morning, provide stable color to your wines over time. And then they also might decrease the astringency. They change what sort of mouthfeel sensation you're getting from the tannin by modifying it. So what this study was really looking at was how does different effects such as berry maturity and alcohol manipulate the amount of pigmented tannin or polymeric pigment that you're going to get in your wines. So in terms of extraction into wine, anthocyanins reach a peak at about 3 days maceration on the skin. So they're relatively quick extraction. Tannins take a little bit longer, and it's a much more complicated extraction, but what we know is that with higher alcohol content, you get more of a degradation of the cell wall, you get more extraction of the tannins. And then once you have anthocyanins and tannins in the same solution, then they start reacting to form these polymeric pigments, which then sort of continue to form throughout the life of your wine. So how berry maturity impacts this, this is very similar to what Thibaut just presented. What we see in Washington, this was from 2015, this is cab. But we saw sort of a maximum anthocyanin accumulation at about 25 bricks. And as you can see, we see accumulation with bricks accumulation, and then we do see a little bit of a decline. Not a super dramatic decline, we're not seeing about 40% remaining, but we do see some leveling off late season from degradation and late season oxidation. The issue with this is that once you start talking about how much anthocyanin is in the fruit, is really how does that correlate to what your wine's going to have. And so you sort of get this bad relationship. This is from a study that Harbison and Keller did back in 2012, or I'm sorry, the vintages are 2007 through 2009. And what you can sort of see is that with more fruit anthocyanin, you are getting more wine anthocyanin. But that's not always a clear relationship. What you end up seeing is you see very specific vintage effects and very specific cultivar effects. So for instance, in 2008, which are these triangles on the left side here, you do see that we didn't get very much fruit anthocyanin, but you still can get a lot of wine anthocyanin. In 2007 and 2009, you see more of this general trend over here on this side, more fruit anthocyanin, it's more clear you're getting more wine anthocyanin. That's not always the case, it's just not always a super clear relationship. Now, the bigger issue is once you come to tannins. And so over time with maturity, you do see a slight decline in seed tannins. Skin tannins tend to stay about the same without maturity. But then once you try to correlate what's in your fruit to what's in your wine, you get some sort of gunshot blast that looks like this. So there's a very bad correlation between how much tannin you get in your fruit versus how much tannin you get in your wine. This study was actually done, all these fruits were harvested at the same maturity, and then the wine was made exactly the same. So this was a very controlled experiment, and you still see this much variation. So it tends to be an issue when you try to correlate maturity and fruit to wine tannin. So what we were looking at in this study was how does berry maturity, how does wine alcohol then impact these precursors, so anthocyanins and tannins, to then form polymeric pigments over time. Adjusting maturity then is adjusting your anthocyanins, adjusting alcohol was really adjusting our tannin extraction. And then doing that also adjusted our anthocyanin to tannin ratio. So it has long been thought that there's this sort of ideal ratio between the amount of anthocyanin you have and the amount of tannin you have to form polymeric pigments. So we wanted to do that to test if maybe we could find a good ratio of the two. So the way that we did this, we did Syrah and Cabernet Sauvignon. We harvested at 3 different maturities, so unripe, ripe, and overripe. We were shooting for 20, 24, and 28 bricks. Once we got that fruit in the winery, what we then did was bleed off and a water back, or bleed off and a chaptalization, to try to replicate the other fruit maturities in terms of final alcohol concentration. So for example, when we picked 24 Brix fruit, I had 3 tanks that stayed as 24 as my control, 3 tanks that got watered back, bled off first, and then watered back to keep the same final volume, to 20 Brix, and then 3 that were bled off and then chaptalized up to 28. So then you have a set of what maturity was it harvested at, and then what was the final alcohol for all of these. So what this then correlated to, we had 54 total wines. I'm not going to go through the winemaking procedure completely. The only thing, we're on a 200-liter scale, so it is a smaller scale. But the only thing that's a little bit different is we do a simultaneous ML fermentation. It's about 48 hours post-primary inoculation. We've never had a problem with VA, and we haven't seen any real color changes, so that's the one thing that we do a little bit different. What happened was I let these wines ferment for 10 days on their skins, and then at day 10, I pulled them off. And I removed the remaining sugars, if there was anything left, and the organic acids just with a chromatography method. And then they were redissolved back into model wine, sort of so they would have the same concentration. And then because polymeric pigments can take a long time to form, they are formed throughout the cellar life of your wine, we did an accelerated aging, so we put these wines at 30 degrees Celsius for 4 months and then sampled once a month. We did analysis of polymeric pigment, anthocyanin, tannin, total phenolics, all by protein precipitation assays in combination with bisulfite bleaching. So I'm just going to quickly talk about growing degree days in Washington. What it sounds like, we had a pretty similar experience in Washington in 2015 that you had here. It was a very hot year for us. This graph comes from the WSU headquarters in kind of a cooler region of the state. So this is in Yakima Valley. So you can see in 2015, we had about 3,100 growing degree days in Yakima. I will just say the cab came from a warmer site. It was from the Wahluke Slope in Washington, which had about 3,600 growing degree days, whereas the Syrah came from the Horse Heaven Hills. That was about 3,500 growing degree days in 2015. So just some harvest data. What we saw, even though we had a really hot year in 2015, we still had 3 to 4 weeks between our pick dates. So we still had plenty of time for the berries to change. The pH and TA are kind of what you would expect. We see a decrease in acidity as the riper the fruit gets. One thing to notice for our berry weights, we didn't see any berry shrivel in Cab in 2015, but you can see that we did for Syrah see quite a bit of berry shrivel down just at this overripe time point. For anthocyanin in the fruit, what we see is that the ripe for both Cab and Syrah had the most anthocyanin, and then we did see some decline in the overripe fruit just from late season. This, however, didn't totally correlate to our wines. So the fruit had the most anthocyanin when it was ripe, but here we have ripe and overripe have the same amount of anthocyanin. Anthocyanin content was not impacted by alcohol treatment. So let me back up a little bit and just say this table. Anytime you see unripe, ripe, or overripe, that just means the fruit, the maturity it came into the winery at, regardless of what was done to the alcohol. In alcohol treatment, it doesn't matter what ripeness it came into the winery at. It was just sort of what the final alcohol was adjusted to. So what we see is that the anthocyanin was only impacted by the fruit maturity. The alcohol content didn't do anything to change that. The tannin, in 2015, we did see that unripe fruit had a little bit more tannin in it, in the wine, than the ripe or overripe. That was unusual for us. It wasn't what we had expected, and we didn't see it in 2014 or 2016. What we see there generally is that tannin is really just impacted by how much alcohol is there and how much it's getting extracted into the wine. So you see we have the high alcohol wine has significantly more tannin than the low or medium alcohol wine. This also gave us the range of anthocyanin to tannin ratio, so we're down at a point about 0.36 and then all the way up to 0.9 for the ratio between the two. And that is for Cab. For Syrah, you see very similar results. Here we saw that the overripe fruit had significantly more anthocyanin than the ripe or unripe. And you also then see a lot less tannin in Syrah just from cultivar differences. but our ratio here is now up at about 1.3 to 2. So we're working in a very wide range of anthocyanin to tannin ratios between these two sets of wines. What happens over time is that we see an exponential decay of anthocyanin. So the amount of monomeric anthocyanin in your wine declines exponentially. What we saw, I also compared cellar age samples to my incubator samples, and what we saw was that 1 month in the incubator was about 1 year at the cellar. So down here on the x-axis is in months. You can kind of roughly translate that to years in the cellar. So you see this exponential decline in anthocyanins. Over time, it wasn't impacted by the alcohol content at all. But what happens is we see this increase in polymeric pigment. So you're losing a lot of your anthocyanin, but you're not losing your color because it's then coming across in polymeric pigments. The tannin, because the tannin was impacted only by alcohol and because the anthocyanin was only impacted by maturity, you end up seeing that polymeric pigment is dependent on both, which makes it a little bit complicated, but we see much bigger differences when you look at berry maturity as compared to alcohol. So what you can see here is that for Syrah, the unripe fruit had significantly less polymeric pigment than ripe, and then overripe had the most polymeric pigment in it. You're seeing this sort of max at about, 1 to 2 months. And so that's about 1 to 2 years in the cellar that we're seeing a max in polymeric pigment content. And so this also, you see is sort of a leveling off and a stabilization of the polymeric pigment that's in the wine. And so this sort of suggests that the formation of polymeric pigments is stabilizing the color that you have. When you look at just a pretty simplified PCA of this, what you end up seeing is that anthocyanin and maturity are right on top of each other, and tannin and alcohol relate very closely together as well. You also see that this is max total polymeric pigment. You see that that's a lot closer to anthocyanin and maturity than it is to tannin or alcohol. And so for Cab, what you can see when you kind of group these by maturity is that you have the ripe and overripe fruit over here with a lot more color, and the unripe fruit kind of over here with a lot less color. And you see something very similar with Syrah. It's a little bit shifted, but you see maturity and anthocyanin are sort of right on top of each other. Tannin and alcohol are right on top of each other. But the big thing here is that the total polymeric pigment is very closely related to maturity and anthocyanin. Syrah, again, we see a little bit more of a breakout between the ripe and overripe maturities here in Syrah than we did in Cab, just different varietal differences. So what we were really setting out to see in this experiment was, is there one single predictor that can tell you how to get more pigmented tannin, how to get more polymeric pigment in your wine? And slightly surprisingly, what it was for us was initial wine anthocyanin content. So you see, as your initial wine anthocyanin increases, you get more polymeric pigment in your wine. For Syrah, we had an R-squared of about 0.7. If you look at sort of the other parameters, our anthocyanin to tannin ratio was actually a pretty terrible predictor of how much total polymeric pigment you'd get. There was really no relationship between anthocyanin to tannin ratio and the amount of polymeric pigment that you got. Tannin in Syrah did an okay job predicting it, whereas in Cab it did a terrible job again. We think that this can be explained by the fact that in Cab you already have quite a bit of tannin, so our low alcohol treatment already had 800 parts per million tannin. So when you already have that much, adding more is not doing a whole lot for you. If you end up adding together the concentration of tannin and anthocyanin, you can predict very well how much total polymeric pigment you're going to get in your wines. So for Syrah, we had 0.86, and for Cab, it was 0.77 R-squared. So just some conclusions of this study. It was initial wine, not necessarily fruit anthocyanin, just because that correlation is not always very clear, is the best predictor for long-term polymeric pigment and long-term pigmented tannin in your wine. So the more color you have initially in your wine, the more tannin you have initially in your wine, the more long-term polymeric pigment you're going to get. So the more softening of that mouthfeel you're going to get, the more long-term color. The other thing was that polymeric pigment was formed relatively rapidly. We saw the max at about 1 month, which is about 1 year in the cellar. which previously we had thought that maybe this process took a little bit longer than that, but we saw that it was relatively quick. So just some acknowledgements. I'm not going to run through all of these, but thank you for having me here today. And I do have to say thank you. St. Michel Wine Estates donates all of the fruit, and they pick the fruit for us. So that's a big help for us. So just thank them. Thank you. That doesn't look like.
Yes, I think it's different question.
Yeah, not
but
for
maybe
me.
somebody has a question for you. Are there any questions to Caroline?
All right.
Thank you very much, Caroline. Okay, so very interesting talk. I think the take home I get is that it makes a lot of sense to track color with some grain of salt as far as how we can predict what's going to happen in the wine. But there is a lot of things to learn in the color. Before I introduce our next speaker, I wanted to answer a few questions. How do microsprayers affect color accumulation in relation to hot, cool sites? So I can only answer the first part of the question. How do microsprayers affect color accumulation? The relation to hot or cool site is so site-to-site dependent. So if I understand well, the question would be, you are in a cool site. Is microsprayer as efficient as if you are in a warm site? Is that the question? Well, the only thing I can say is that through their effect on lowering canopy temperature, the use of microsprayer is very useful. It can drop it by 2 or 3 degrees Celsius, but instead of keeping it long, just check. There has been an article published last month on the Australian Journal of Enology and Viticulture by Cassandra Collins, specifically on that. And you will see actually how different misting programs affect the efficiency of temperature reduction. So I leave it at that. Caroline, there is a question for you. Does your work imply cold soaks are important for final color of wine? Can you give a microphone to? So is your cold soak important for final color of wine?
Sure. So I haven't done any work on cold soak, but I know that the understanding is that if you cold soak, maybe you'd get more initial anthocyanin in the wine. And sort of what we saw is that whatever it takes to get more initial anthocyanin does sort of correlate well with final wine color. So I haven't personally worked on cold soak, but if you're seeing more color initially from a cold soak, then I would assume that it would help.
Okay.